Welcome to another great Cal Basic demonstration. This is part 5 of a 19 series set of videos for the 16F171 chip family. So let me just turn the camera on. Hi, my name is Venn. If you do like these videos or the suite of videos or any of my videos, please press the like key down below. Otherwise, I won't know who's liking them, who's disliking them, but do like them. Okay, let's get cracking on the video what we're covering. We're just going to do a really simple input. So we're going to use the input on the microcontroller to set the state of the LED. It'll be LEDs because all four are attached. So, bit of prerequisites. See the other videos. I'm not going to go into the details of the chip anymore because we're in the 5th video. So what am I using? I'm using a microchip low pin count demo board. It's like this on the left hand side there. You can make your own, and if you go back to the previous videos or into this PowerPoint, you can see how to make your own layout. What does that look like in reality? That looks like one of these things. Here's the chip plugged in. It's plugged into a PIC16F17126. It's got 4 LEDs and a switch, and I'm going to be pushing that switch here today. And when I push the switch, the LEDs will come on. It's quite a simple demonstration in reality, but the code we're going to be using is always not that easy. But we have to just go through it, okay? All right. So the switch is connected to RA3, which is port A.3, and when you press it, it will transition the voltage from high, at 5 volts, to 0 volts, and that's done through a series of resistors shown in the diagram. And that diagram is from the data sheet, so you should be able to replicate the port, this port pin setup. So you've got 5 volts on the V rail there being pulled up through a 10k resistor. And then so when I push the switch down, it transitions to 0. Quite simple. So what we're going to do in our program is, I'll just turn the video off, is we're going to initialize the board. We're going to check the state of the switch using a function. And if it is true, as in the logic statement there, it will toggle the LEDs on or off. We've seen how to toggle things using the not statement, and if not, it will just loop around until we change the state. So it's quite simple little program. But so because it's so simple, we're going to look at the code, look at the results, and then we're going to change from a PIC2 to a 3 to a 4, just so you can see that you can use different programmers. I've been using one type. We can use many different types. So with that, let's go to my desktop, Windows, GCStudio. It comes up automatically on mine. Should do on yours too. And then I end up with the splash screen. I'm just going to select chip range demonstrations. And in we go. This is where we left it yesterday. So I'm just going to close that down and have nothing in my editor. I just see the logic, the cow. And I'm just going to open up the Explorer. I can see all the files in here. I'm just going to press Control F just to filter on the GCB files, the source files, and press the down pyramid. Debounce the switch, 070, debounce the switch, double click, and we're in. Shut the Explorer, don't need it anymore. Right, what have we got? Oh, look, we've got 16F17126. We've got a set of constants, which you've seen before, but today I've added in some more constants. I've defined a constant called switch in on port A3, and then I've said to it, switch in, that constant switch in is direction is an input. And I've defined a constant called down. I use that constant because sometimes a switch state might be high, this 1, or 0. So you can just toggle that 1 constant to change the whole of the logic of the program. So here's the whole program. Do forever loop. This is just a constant in, basically means do it forever. Wait 10 milliseconds. And here it is. If the function, if func as a function, func key pressed equals true, then do something, and all it's going to do is toggle the LEDs on and off. That's it. So I'm going to program it now, and then we'll go into the depth of the code. So I'm going to select hex and flash. You can see in the camera, it's now flashing the chip, and it's done it. So if I push the button, the LEDs toggle. How does it do that? Because of this test. What is that test? Let's have a look at it. We're going to use a function, and it returns a bit. We've seen a word before, we've seen a byte, now we're seeing a bit. And I'm initializing a couple of bit variables, one called current switch state and last switch state. So the current switch state is the current state of the switch, and it retains the last switch state, and it's going to compare the two at some point. Wait 1 millisecond. We've seen that before. An if statement. If switch is down, then the current switch state is true. If it's false, it's easy. Now I've done it that way just to make it a bit clearer for you, that you can then use true and false. So this is equivalent to a 1, equivalent to a 0. If this is a word, it would be slightly different, but it's still true or false. So I'm setting the current switch state to true when it is down. And then essentially I say, is it equal to the last state? If the current switch state is not equal to the last switch state, then we're going to send back to our program true or false. The last switch state is the current switch state, that's a cache, and then return back the current, the functional return, and that's going to be true. Else, return false. That's it. That's the program. It's as simple as that. It says, has the key been pressed? If it's true, therefore it's been pressed, it's toggled, it returns true. So look, what I'm going to do now is just, has it programmed it yet? Push that button again. Now what I'm going to do is I'm just going to swap out PIC16F17126 for PIC16F17126. I've changed it, make hex and flash, and it's just going to flip that over, and it finds the PIC16F17126 and just works. That's great. Now I'm going to use a PIC16F174. For PIC16F174, I do need to do something beforehand. I need to set a particular little bit inside the chip, and I do that by erasing the chip, and then after that I can use a PIC16F174. So let me just go to my desktop, and I'm going to start up the PIC16F173 software. Just erase the chip, and I can do that by pushing the erase key. Now the chip is erased. If we go back to our camera, you can see it's erased because if I push the button, nothing has happened. Now, take the PIC16F173 away, change to a PIC16F174, plug it in. There we go, PIC16F174. To make this work, I just need to change my programmer preferences. And if you remember, we did that by pressing function key F4. We typed in prefs, and it brings up edit programmer preferences. And then I look in this big long list, and I find the PIC16F174. Here we go. MPLAB IPE, PIC16F174, command line interface, 5 volts. That's what I need. I'm just going to program that. I say, okay, sorry. And I'm going to change my program slightly. And I'm going to put it a configuration, hash config. This is I'm changing the configuration of the hex file it's going to be produced. And I'm going to tell the PIC16F174 to use low voltage programming. Press F5. It compiles it the same. It's now setting the bit within the configuration LVP, low voltage programming, equals on, And we've now enabled a PIC16F171. This is using the latest version of MPLAB, IPE as its core, and it's now done it. If I now go out to here, I can push the button, and hey presto. Oh, it's turned the volts off, of course, because it won't supply the volts afterwards. I just love the PIC16F171. So I need to put volts up back on the board. So I'm just going to return back to my PIC16F3. Is that what I have here? Yeah, back to my PIC16F3. Stabilize the cable. I can leave that there if I wanted to. Back to programmer preferences. Just remove by dragging down the PIC16F171, and I'm now back to my quicker PIC16F3. Close that, push that button, and we're operational. Great. Let's go back to PowerPoint. So what we wanted to do was use an input to set the state of the LEDs. Demonstration 5. The next part is to use the reset switch, the same button, but reset the whole chip. So what we've been using the switch as an input, but we can actually use that as a reset and turn that on and off, and we'll go through that by changing the configuration. And with that, we'll call that a wrap.